What do a robot arm, a flying drone, and even your own hand have in common? They all move in space smoothly, continuously, and most importantly, predictably. But what is motion, really? How do we mathematically describe a rotation, a slide, a twist? And what does motion have to do with lie? Well, the truth is, it's not lie, it's the Lie group, one of the most powerful and least understood ideas in mathematics that govern the motion of anything. If I rotate this globe 90 degrees, it's still the same globe, just facing a different direction. Now here's the interesting part. Every possible orientation of this globe can be described by just one mathematical object, a rotation matrix. And a set of all these rotations, taken together, forms something called SO3. That's a Lie group, but don't worry, we're gonna break that word down. Named after the Norwegian mathematician Sophus Lie, and yes, it's pronounced Lie, not like telling a lie. It's Lie group. Lie group are how mathematicians describe smooth, continuous symmetries. Think of a Lie group like a magical toolbox that lets you do any motion you want and reverse it without breaking the rule of space. Take a door hinge. You can open the door to any angle between 0 and 180 degrees. That's a continuous transformation. You're not teleporting the door, you're rotating it smoothly. And if you open the door halfway, then open it another quarter, you're essentially combining two rotations. That combination follows a rule, group structure. You can do one rotation, then another, and the result is still a valid rotation. So rotation form a group, and because you can do them smoothly, infinitely small to infinitely large, they form a Lie group. Imagine stretching and twisting a rubber band without tearing it. Every way you stretch, it's a transformation. If those transformations follow a smooth pattern and can be undone, that's a Lie group. Now why should we care? Because if you are building a robot arm, or a drone, or an autonomous car, you need to describe every possible configuration that robot can take. And guess what? Those configurations form a Lie group. So understanding Lie groups isn't just academic, it's the language of motion. Let's take the group SO3. It stands for Special Orthogonal Group in 3 dimensions. Sounds fancy, but it just means all the 3x3 matrices that rotates objects without stretching or flipping them. Every rotation in 3D space is one of these matrices, and all of them together make up the Lie group SO3. What's beautiful is that we can even describe tiny motions, infinitesimal ones, and build up big ones from them. That's what Lie did. He figured out that if you understand infinitesimal motion, you can understand all motion. That's the job of the Lie algebra. It's like the DNA of the Lie group. It's kind of like walking. You take one tiny step and another and another. Each step is small, but combined they take you across a room. That's what Lie algebras do. They describe the baby step. The Lie group is the full walk. So every time we spin a globe, fly a drone, or move a robot arm, we're living inside a Lie group. It's the mathematics that govern how things move in our world and beyond. The secret language of motion, symmetry, and control has been hiding in plain sight. And it started with a Norwegian mathematician over 150 years ago, asking, what happens if we zoom in infinitely close to a transformation? The answer was the Lie groups. Thanks for watching, and if you don't mind, please subscribe.